Hello, my name is Asia Farrar, and I'm here to present to you my podcast for Dr. Lewis's differential equation class. Today I'm going to solve this equation, and I'm going to use the Bernoulli method. When looking at the Bernoulli method, you always got to think about y being to a specific number. In this case, we have y to the fourth. So I'm going to use the Bernoulli method. So first step I'm going to get all the x's on one side and get all the y's on one side. So I'm going to separate the variables. My problem is 4 times 1 plus x squared times dy over dx equals 2x times y to the fourth minus 1. The first thing I'm going to do, I'm going to try to get all the x's on the right-hand side. So I'm going to divide this whole side by 1 plus x squared. And I'm going to also divide the same thing by this side. Once I divide that, I can cancel those two out. And now I only have 4 dy over dx is equal to 2x y times y to the fourth minus 1. And that's all over 1 plus x squared. Now, I'm going to multiply both sides by dx to get all the x's on the right side. Those two dx cross out, and I still notice I have y's on this side. So I have to divide this whole side by everything that's y. So that's y times y to the fourth minus 1. I'm going to do the same thing to this side. Y times y to the fourth minus 1. These cancel out. And I'm just going to erase everything that I canceled out so you can see it more clear. So all I have on the right-hand side is 2x dx over 1 plus x squared. And on the left-hand side, I have 4 dy all over y times y to the fourth minus 1. Okay, so now that we have separated the variables, I'm going to set it equal to each other. Now that we have separated the variables, I'm realizing that I'm going to have to use u substitution. In this case, y to the fourth will be u, but I kind of want to make this y u2, so I'm going to multiply the top and bottom by y to the third. So top and bottom times y to the third, so I can have this is u, so it's going to be u times u minus 1. So the top times y to the third is 4 y to the third dy all over y to the fourth times y to the fourth minus 1. And this is still equal to 2x dx over 1 plus x squared. Okay, so I'm going to write on this side, I'm going to write what u equals, what du equals, and d is dv. If you missed the top part, just remind me because the board is kind of small, so I have to erase. Okay. So, u, like I said, is going to be y to the fourth. So I've got u is y to the fourth. So that means du will be 4y to the third. Okay. So I'm just going to substitute the U's in for everything else on that side, and the DU's for everything that I see on that side. Okay. So DU is actually 4y to the third dy. Okay, so this side will now be, plug this in, so it's going to be du over u minus times u minus 1. So that's what we have for the left-hand side, and now we still have the right-hand side as 2x dx 1 plus x squared. So let's erase this. Alright. And for this side, the v is x squared, and dv would be 2x dx. So we see that 2x dx is at the top right here. Can you see that? Oh, you can. 2x dx is at the top, so we're going to just put dv. Let me just write it underneath. dv, and so that's going to be 1 plus v, because v is equal to x squared. 1 plus v. And then we have du over u. Okay. Okay. So right now we have du over u times u minus 1, and that is equal to 1 over 1 plus v dv. So the next step we're going to do is, we're going to separate this into two different equations. So separating this, we will get 1 over u minus 1 minus 1 over u du. So basically I just broke down this equation and made it into two separate equations, because I'm going to end up taking the integral of both sides. So, and now if I was to take the integral of this, we know that 1 over x, the integral of that is ln x. But in this case we have 1 over 1 plus v. In this case, v will be the x, so it's just going to be ln 1 plus v. That's what we get when we integrate on the right side. Oh, plus v. So, next we're going to integrate this side. We integrate this side, like I said, ln, or the integral of 1 over x is ln x. So it's going to be ln u minus 1 minus ln u. And that is equal to ln 1 plus v. Let's see. I'm going to give you guys a second to take that in, because that was a lot of information. Like I said, I broke this up into two different equations so I can take the integral of the right side, for the left side and the right side. Next step, I'm going to set all of this equal to c. We'll have c on one side. So once I do that, I'm going to erase the top now. Once I do that, so I'm just going to have ln u minus 1. You see that? Yeah. ln u minus 1, u times 1 minus b. And that's equal to c. Once we raise this equation to the power of e, that's going to cancel out this ln. So I'm going to do that right over here. Cancel it out. You're going to get just u minus 1 over u 1 minus b. Oh, still equal to c. And I'm going to get rid of this fraction right here. So I'm going to multiply the top, or no, multiply the bottom, the denominator, by both sides. So that should give me u minus 1, and that's equal to u minus 1v, u minus 1v, this is a v, c. So once I plug, I'm going to have to plug everything back in. U again, I wish I didn't erase that. U again was y to the 4th. So once we plug in that, we're going to have y to the 4th minus 1, and that's equal to y to the 4th minus 1. Oh, no. Y to the 4th times 1 minus b. And b, what was b? B was x squared. Okay, minus x squared. C. Okay, so this is how I solved my Bernoulli differential equation. If you guys missed a step, just rewind. I know my board was kind of small, but I had to work with what I got. So thank you very much, and I hope you enjoyed my podcast.